Hi students, good morning. Now we can discuss more about redox reaction in this slide. Okay, so we discussed about the oxidation, how to assign oxidation number and all. Today, here we are going to discuss about the different type of redox reaction. The first type is combination reaction. From the name itself, what we can understand, two elements combine together and form a compound. Okay, so that type of reaction is called a combination reaction. Combination reaction, usually the reactant must be elements and their oxidation number should be 0. Okay, so let us see some example. Here we can see example C, carbon and oxygen. All these reactants are in the elemental form. So carbon is converting into plus 4, so this is undergoing oxidation. Oxygen is converting into -2, so it is undergoing reduction. So it is a redox reaction. Again, magnesium from 0 to +2, nitrogen from 0 to -3. So this is also redox reaction. Here also another reaction we can see. Here carbon is and hydrogen is undergoing oxidation. So carbon with it is a hydride. So with the hydride, carbon is having minus oxidation number because hydrogen is having +1 oxidation number here. So this is -4, but carbon dioxide it is +4. +1 become, for hydrogen there is no change, but oxygen is changing from 0 to -2. So the oxidation number of carbon is increasing, so it is oxidation, and for oxygen it is decreasing, so it is reduction. Okay. Now let us discuss about the decomposition reaction. Actually, the decomposition reaction is opposite of oxidation reaction. So opposite of a combination reaction. Combination reaction means A plus B gives C. Two elements combine to form a compound. Here A compound undergo decomposition to form two elements. Okay. So here product side they have zero oxidation state. Okay. So let us see that reaction. Here let us see few reactions of that. That is here water is undergoing decomposition. See, water, hydrogen is having +1 and it is converted to 0. So it is reduction. Oxygen -2 to 0. It is oxidation. The number is increasing. And sodium hydride becomes sodium and hydrogen decomposition. So +1 to 0 for sodium reduction and -1 to 0 for hydrogen oxidation. So here chlorine +5, and for this here chlorine is having -1 oxidation state and oxygen is having 0 here and -2 here. So oxygen is undergoing oxidation and chlorine is undergoing reduction. Okay, but we cannot believe that all the decomposition reactions are redox reaction. There are some reactions which are not redox reaction. Let us see that case. In calcium carbonate, when it undergo decomposition, you are getting calcium oxide and carbon dioxide. So all of these, if you look at this oxidation number, you can see that none of the oxidation number is changing. Calcium +2, calcium +2, carbon +4, +4, oxygen -2 here, oxygen -2 here. So if none of the oxidation number is changing, that means the reaction is not a redox reaction. Okay, now let us see displacement reaction. Already we have discussed, that is the most reactive element will replace the least reactive element. That is called a displacement reaction. And displacement reaction we are categorizing into two: metal displacement reaction and non-metal displacement reaction. So let us see first metal displacement reaction. We already seen these reactions here in competitive reaction. So here copper sulfate when added to zinc, zinc is more reactive, so it will displace copper and it will form copper plus zinc sulfate. Okay. So the oxidation number of the most reactive metal will be always undergoing the oxidation, and the least reactive metal will be undergoing the reduction. Understand? That is what happening in competitive reaction. Here calcium is most reactive metal, that will be undergoing oxidation 0 to +2, and vanadium +5 to 0 reduction. Here magnesium is most reactive, so magnesium will undergo oxidation 0 to +2, and titanium is least reactive, so it will undergo reduction +4 to 0. Okay, here aluminum is most reactive, so 0 to +3 oxidation, and chromium +3 to 0 reduction. Okay, so this is metal displacement reaction. Now let us see some of the reaction that is non-metal displacement. That is the reaction of alkali metal with water. When you put a sodium in water, it will liberate hydrogen. Sodium or metal, if you are putting in water, it will liberate hydrogen. This is an example here. Sodium, always metal will be acting as a, because metal is always undergoing oxidation because they are electropositive. So metal will be acting as a reducing agent. Metal will be reducing agent and non-metal will be oxidizing agent. Okay. So Na to Na plus 1 means it is undergoing oxidation and it will be acting as a reducing agent. Calcium also is acting as a reducing agent here. Now, let us see the reaction of water with fluorine. It is producing hydrogen fluoride and oxygen. So fluorine, look at fluorine. Fluorine is 0 to minus 1. So it is undergoing, it is a non-metal, it is undergoing reduction. So it is a better oxidizing agent. Okay. So it's the best oxidizing agent because fluorine is most reactive also. So plus 2 minus 2. Here oxygen is minus 2 to 0. So it is undergoing oxidation. Now, another type of metal displacement reaction we have to see, that is, if you look at the reactivity of fluorine, chlorine, bromine, and iodine, the fluorine is most reactive, and so fluorine can displace all the element which is coming below that. Okay, so fluorine, when react with sodium bromide, fluorine has a tendency to displace bromines and it will form sodium fluoride and bromine. So here, 0 oxidation number become minus 1 oxidation. It is undergoing reduction and it will act as a better oxidizing agent. Okay. Now, disproportionation, a very important reaction we have to learn. This is very, very important. In displacement, so far what we have discussed is if a particular element is undergoing oxidation, another element will undergo reduction. But in disproportionation reaction, in a particular reaction, both oxidation and reduction is done by only one element. Okay, that is called disproportionation reaction. So let us see one example. In this case of H2O to C, hydrogen, the oxidation number is not changing. Oxygen C minus 1. Hydrogen peroxide, we discussed in the rules of oxidation number. Oxygen is having minus 1 oxidation state. And that is converting into, after decomposition, it is converting into water and oxygen. So in water, oxygen is having minus 2 oxidation number. In oxygen, it is having 0 oxidation number. So oxygen is undergoing reduction here and oxygen is undergoing oxidation here. Since the same species undergoing oxidation and reduction, this reaction is categorized as a disproportionation reaction. Okay. Next example for disproportionation reactions are phosphorus. 0 to pH3. Here it is minus 3. H2PO2, it is having plus 1 oxidation number. So both of reduction and oxidation. Sulfur, again, minus 2 here and plus 2 here. So both oxidation and reduction. Chlorine, plus 1 here, minus 1 here. So both oxidation and reduction will undergo in a particular reaction, the same species. So that reaction is called a disproportionation reaction. Now we are going to discussing about balancing of redox reaction. So two methods are there, but this is very important. You have to understand how to do this. Okay. So oxidation number method we are discussing. Okay. So oxidation number method. In oxidation number method, let us take first one question. Let us take a question, that is Cr2O7 2 minus is reacting with the potassium dichromate is reacting with the SO3 2 minus. Okay. And it is converting into Cr3 plus and SO2. Okay. It's 1 minute, 1 second. So let us see the question again. This question, Cr2O7 minus is converting into SO3 2 minus. Yes. SO3 2 minus and SO4 2 minus. Okay. 2 minus. This is the question. And this reaction is taking place in acid medium. Suppose this reaction is taking place in acid medium. Okay. In this particular case, let us see how we will balance this reaction. So first, we have to write a correct equation like this. Okay, Cr2O7 2 minus is reacting the SO3 2 minus, and it is converting into Cr3 plus and SO4 2 minus. That is the first step. Okay, now what is the second step? Now we have to see the second step. In the second step, we have to assign the oxidation number of each one of this. Okay. So in chromium, Cr2O7 2 minus. This 2 minus belonging to the charge of the entire molecule. Okay, and their species. So put X and oxygen we know minus 2 it is. So now 2 into X plus minus 2 into 7 is equal to minus 2. Okay. So 2x minus 14 is equal to minus 2 we will get. 2x is equal to minus 2 plus 14 we will get. 2x is equal to plus 12 we will get. X is equal to plus 6. So what is the oxidation number? Chromium is here plus 6. Okay, now SO3 2 minus we can see. SO3 2 minus overall charge, sulfur X, oxygen minus 2. Put X plus minus 2 into 3 is equal to minus 2. So X minus 6 is equal to minus 2. X is equal to minus 2 plus 6 is equal to plus 4. So the oxidation number of sulfur here is plus 4. Now we are seeing Cr3 plus. Already is a monoatomic ion it is, so its oxidation number is 3 plus only. And sulfate, SO4 2 minus ion, we are finding out that also. SO4 2 minus, sulfur X, oxygen minus 2. So X plus minus 2 into 4 is equal to minus 2. So X minus 8 is equal to minus 2. X is equal to minus 2 plus 8, that is equal to plus 6. So in this way, we are assigning the oxidation number. This is plus 6. So for oxygen everywhere, we found that it is minus 2. So now we can see what is happening to chromium, each one of this. So second step is assigning the oxidation. First write the correct formula, then after that assign the oxidation number, we assigned it. Okay, now after that what we have to see is, look at chromium. What is happening to chromium, to the oxidation number? Plus 6 become 3 plus. How plus 6 become 3 plus? By adding 3 electron only it is possible. So if you add 3 electron here, plus 3 minus will come. So it become 3 plus, right? So here plus 4 become plus 6. How it is possible? It is increasing by removing minus 2 electron. Okay, by remove. So here it is adding 3 electron and here it is removing 2 electron. Okay, now we have to equalize the number of electron which is removing and adding. So in order to make it equal, you can multiply this number with 2 and this number with 3, so that it becomes 6 electron and this also becomes 6 electron. So whatever number you used to multiply, that number you have to multiply on the right hand side where it is on the sulfur. Okay, 3. Here for chromium, we multiplied with 2, so that we will put 2 here. Okay. So we use the number 3 to multiply 2 electron and to get a 6 electron. So the same number right hand side on the same species, left side we have to add. And here also we use the number 2 to get 6 electron. That right side you have to see which is the species chromium. So left side of that we have to add the 2 also. We have to put 2 over here. Okay. Now the next step, so third step is finished. The fourth step is balance both sides now. Now here is Cr2O7 2 minus plus SO3 2 minus gives 2Cr3 plus 3SO4 2 minus, right? So this is the one. Now we have to see chromium is balanced. Yes, all the atom other than oxygen and hydrogen we have to balance. So Cr2 here, Cr2 here. Sulfur is 1 here, but sulfur is 3 here. So you will balance it, finish. That is the fourth step, balance the atoms. Okay. Now, other than oxygen and hydrogen, the fifth step is we have to find the charges. Okay. Total charge on this side and total charge on this side. So here 2 minus. So 2 minus 3 into 2. So minus 6. Okay, minus 2 and minus 6. So total we have minus 8 charge here. And what is the charge here? 2 into 3 plus 6 plus 3 into 2 minus 6. So total charge here is 0. So we have to make here. So the total charge here is 0 and total charge here is minus 8. So what we need to do is we have to here, which is lowest number we have to find it. 0 is the lowest number. So we have to make it lowest number. Okay, the minus 8 and 0, right? So we here it is the charge is 0. So here also we have to make it to 0. So how we will make it to 0? Here minus 8 and here 0. So since here it is 0, we have to make it to 0. How we will make it to 0? By adding H plus ion. Since it is acid medium, we have to add H plus ion to make it 0. Okay. So how many H plus ion we have to add? Minus 8 it is. So we have to add 8H plus. So then only it becomes 8 plus. Then it becomes 0. So both the side we are matching the charge equal to 0. So this side also 0, this side also the charge equal to 0. So the final equation we got is Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus, that is equal to 2Cr3 plus 3SO4 2 minus. Now our next step is balancing the hydrogen atom. So how many hydrogen atom is there? 8. So balancing the hydrogen atom, we are adding half of this water molecule. Okay, 8H plus is there, so half water you add because 4 into 2 is 8. Okay, now we can see the oxygen is balanced or not. If you add the water molecule, everything should be balanced. Let us see that. Cr2 is balanced. Sulfur is balanced. Now hydrogen is also balanced. Oxygen we can see. 7 plus 3 into 3. How many? 3 into 3 is equal to 6. Okay. How many oxygen is there? 7 oxygen here. 3 into 3 is 9. Okay. So as a total, 16 oxygen is here. And this side, how many oxygen is there? 4 into 3, 12 plus 4, 16 oxygen. Understand? So all is balanced. So this is the balanced equation we are getting. So what we done is, first we will write the correct formula. After that, we will find out the oxidation number. After that, how many electron is losing and how many electron is adding, we will find out. And we will make the number of electron equal, and how many, which number we added to make it equal, that number we will add, write on the left side of that species, left side of the species, on the right side of the equation. Okay. And then after that, we will balance the charge and equate it to 0 on both sides. And then after that, what we will do, since it is an acidic medium, we will be adding H plus ion to balance the charge. Okay, balance the charge. Okay, here it is 0. So the same charge we have to get here. If here it is minus 2, here also we have to get the same charge. So we are balancing the charge here, equating the charge here to 0 because here also it is 0. Okay. So now how many Cr2, how many H plus ion, we add half of that water molecule we have to add on the right side of the H plus ion in order to, or opposite side of H plus ion, in order to balance the number of hydrogen and oxygen. That's all. Now let us see another example also. Let's see another example also. So we have to see another example that is taking place in basic medium. Okay, so this is another example, manganate and a bromide ion. So let us see this particular example. Okay. So MnO4 minus is reacting with the bromide ion, and we are getting MnO2 and BrO3 minus. Okay, this is the reaction. Okay, So in this particular reaction, this is taking place in basic medium. Okay, let us check again the question is correct or not. MnO4 minus plus Br minus gives MnO2 and BrO3 minus, correct. Okay. So now first is we are writing the all the correct formula. Second step is assigning the oxidation number. So MnO4 minus already MnO4 minus, right? MnO4 minus 1. So x minus 2. So x into minus 2 into 4, that is equal to minus 1. So x minus 8 is equal to minus 1. X is equal to minus 1 plus 8 is equal to plus 7. So this is the oxidation number for manganese. We are already minus 1. MnO2. MnO2. X plus 2 into minus 2 equal to 0 because it is neutral. So x is equal to plus 4. So plus 4 is the oxidation number here. And BrO3 minus 1. X plus 3 into minus 2 is equal to minus 1. X minus 6 is equal to minus 1. X is equal to plus 5. Okay. So plus 5. So this is assigning the oxidation number. After assigning the oxidation number, let us see how many electrons are moving. Plus 7 to plus 4. So here you have to add 3 electrons so that 7 plus 7 become plus 4. Here minus 1 to plus 5. Okay. Minus 1 to plus 5 means after minus 1, 0, 1, 2, 3, 4, 5. So how many electron? 1, 2, 3, 4, 5, 6. So you have to subtract 6 electron, then only we will get plus 5. Okay. So you are removing 6 electron and here adding 3 electrons. So in order to third step is what? Equalizing the number of electron. Here 6 electron, multiply this with the 2 so that you are equalizing the number of electron on both sides. Since into this particular species we multiply with 2, so you are multiplying here 2. Here no need to multiply with any number because it is already 6 electron. We did not multiply with any number here. So now the new equation, our new equation is MnO4 minus plus Br minus gives 2 MnO2 plus BrO3 minus. Now what we need to do is we have to equalize the atoms other than oxygen and hydrogen. So Mn1 here, Mn2 here. So you are putting 2 here. Br minus 1, Br1 only, 1 only. So it is already balanced. Next, we are equalizing the charges. Okay. So 2 into minus 1, minus 2 plus minus 1 here, minus 1. So total charge here, minus 3. Now let us see here what is happening. Here it is neutral. So here there is only minus 1. So this is minus 3. So we have to equate it to minus 3, right? So, but since it is a basic medium, we can add OH minus only. We are not going to add H plus ion here. We are going to add OH minus here. If you are adding H plus ion, we are reducing the charge. Okay. Actually, we are adding H plus ion means minus 3 become minus 1 or something. The charge will be increasing like minus 1. So here minus 1 it is. So here OH minus is the only possibility to add. So we can equate minus 1 to minus 3 by adding how many? 2 OH minus to this side. If you add 2 OH minus, this minus 1 minus 2 will come. So as a total minus 3. So in this way, we can equate the charge on both sides. Okay. We are not adding H plus ion here. We are adding. In the other case, we were minimizing the charge. Here, what we were doing, minus 3 charge we are attaining because we have to add OH minus here. So minus 1, the value of minus 1 become minus 3 by adding 2 OH minus. Okay. So after that, our new equation now is 2MnO4 minus plus Br minus will give you 2MnO2 plus BrO3 minus plus 2OH minus. Okay. This is our new equation. Now you have to, the fifth step is equating the number of hydrogen. Here 2H is there. So we will add 1, half of that. 1 water molecule here. Okay. So that hydrogen is also balanced. Oxygen we can see 4 into 2, 8 oxygen. plus 1, 9 oxygen here. Let us see here 2 into 2, 4 oxygen, plus 3, 7, plus 2 here, so 9 oxygen. So all is balanced here. Okay. This is balancing equation. So one more method is there that we will discuss in another class. Okay. Thank you.